Okay guys, welcome once more to another video again in our YouTube channel. So in today's video we are going to look at the continuation of trigonometry. I recommend that you should watch the other video before watching this one. Okay, so as displayed to you on your screen, so please like the video, subscribe to it and share to your friends so that they can also benefit from it. Okay, you can also reach us on you can also reach me on WhatsApp, as you can see the number displayed to you on your screen, and on YouTube via Mathematics Dreamland for Africa, the MDLFA. Okay, so without wasting much of your time, let's get started. All right, so that is it. Okay, today's video we are going to look at trigonometric ratios. In the other video um we talk of the basics, right? We talk of the basics, how to manipulate a triangle with no angle given. Okay, so today we are going to look at the trigonometric ratios. Now these ratios are very important in mathematics. Yes, they are very important in mathematics. Okay, so we have that the three basic trig ratios are the sine, cosine and the tangent. So the three basic trig ratios are very essential in mathematics. Okay, now we are going to consider, this sign here means, this sign here, it actually means triangle. Okay, yes, this sign means a triangle. So from triangle, yeah, that's the meaning. You can still spell the triangle, or you can still spell it if you want to spell it, but in mathematics that's how they abbreviate it. Okay, so it means that from triangle, so that's the meaning. Now from triangle ABC, the three trig ratios can be derived. Okay, so let me draw a triangle. So that is a triangle ABC. Now from this triangle, right, the three basic trig ratio can be derived. Now this is a triangle. In the last video we only talk about a triangle with no angle. Okay, so now we are going to include an angle theta. Okay, so that is it. That is the angle theta. Now from this triangle we can derive the three basic trig ratios. Now when we do the from the three trig ratios there, right, from these three trig ratios, or the three trigonometric ratios, right, we can derive the other ones like the cosine, the secant and the cot. Okay, or the cotangent. Okay, so let's just look at these three basics for this video. Okay, so I have some hints to give you guys about this triangle. Yes, it's just like a hint. Okay, so now I'm going to define the various sides AB, BC and AC. Okay, so we have that AB equal to hypotenuse. Now this is the length AB, so AB is from here right up to B, so that is AB. And from primary school we know that this length, the longest length of a right angle triangle, is the hypotenuse. So this is a right angle triangle. So in trigonometry we mostly focus on the right angle triangle. Okay, so in this triangle, a right angle triangle is a triangle that there must be an angle that is measured 90 degrees. Okay, so if you look at this triangle, this angle here, this angle is actually 90 degrees. Okay, so that is it. And we notice that AC, from the hint, BC is the adjacent. Why is BC called adjacent? This is BC here, this is BC, the length BC is called adjacent. Now it is called adjacent because it is adjacent the angle theta. Okay, it is nearby, like that is, this is the only length that is nearby the angle theta, and that is why it is actually called adjacent. Now AC is the opposite. Now where is the opposite? This is AC here. AC is the opposite. Okay, so the opposite, why is it called the opposite? Because this is actually our angle theta. Now opposite this angle theta is AC, so that is why AC is actually called the opposite. Okay, so that is it about the hint. Okay, let's continue with our trig ratios. Okay, now we are going to begin with sine, the sine of an angle. Now I recommend that you should be working with your scientific calculator, and also you should be jotting some relevant things about this video. Okay, so now we are going to begin with the sign of an angle. Now, what is actually the sign of an angle? Now, the abbreviation sign is usually used for sine. Now, if you look at a calculator, you notice that here we instead have sine. In a calculator we have sine, not this other sign, okay. But this other sign is just this other sign here is just the abbreviation. This one is just the abbreviation of this one, of this other sign, the sign with e, that ends with e. Okay, so that is it. Now, in any right angle triangle, the sign of an angle theta is given by sine theta equals to opposite over hypotenuse. So these are the basic things you have to know. You have to master them offhand. Okay, so that is it. So opposite. So from our triangle, we notice that this is the opposite. AC is opposite the angle theta. Is opposite this angle theta, and divided by hypotenuse. So our hypotenuse is AB from our hints here, from this hint. Our hypotenuse is AB. That is why I said opposite over hypotenuse. And what from the triangle, what is the opposite? AC is the opposite, and AB is the hypotenuse. Okay, so that is it. Okay, let's look at the other trig ratio. So we have the cosine of an angle. Now, what is the cosine of an angle actually? Now, in any right angle triangle as above, okay, so in this case we are going to consider our own right angle triangle here as above. The cosine of an angle theta is given by, so in similar manner, cos theta equals to adjacent over the hypotenuse. Okay, and from our own right angle triangle, we notice that BC, where is BC? Opposite adjacent over hypotenuse equal to, which is equal to BC over AC, AB. Now, from our hints, what is BC? From our hints here, what is BC? So this is our BC. BC is the adjacent. That is it. This is our BC here. It's the adjacent. Okay, so that will be our cos theta. Okay, so let's look at the tangent. So similarly, the tangent of an angle theta from the triangle above is given by, so let's look at the tan. So tan theta equals to the opposite over the adjacent. Notice that sin theta is different from cos theta, and it's also different from tan theta. So the three trig ratios are actually different. So with sine, we are dealing with opposite over hypotenuse. So this is a sine here. This is a one for sine. We are actually dealing with opposite over hypotenuse. But for cos, we are actually dealing with adjacent over hypotenuse. So you have to know them. And for tan, we are actually dealing with opposite over adjacent. So for sine, it's opposite over hypotenuse. For tan, it's opposite over adjacent. Okay, so that is it. Now, so we have that. I have some mnemonic here that you can use for you to easily record these formulas. Okay, so this mnemonic is actually called SOHCAHTOA. Okay, so that is SOHCAHTOA. Now, how is it useful? Okay, let me explain, because actually it's not easy to cram all these things. Like for example, I can just ask you now, what is the sign of an angle of a right? What is the sign of an angle? So it's actually the opposite over the hypotenuse for a right angle triangle. So that is it. But you cannot just give me all of them at once. So the best way that you can easily recall all of them is by using the mnemonic SOHCAHTOA. So that is it. So what is the mnemonic saying? So SOHCAHTOA, this saw here is actually this saw, yeah, this OH actually means opposite over hypotenuse. Okay, this O here is the opposite, this H here is the hypotenuse. Okay, so let's move now to car. So car, there is H on AH. So but we know that cos is the adjacent, right? Is the adjacent and over the hypotenuse. So we notice that this is the adjacent A and this is the hypotenuse H for car. Okay, so let's move now to TOA, and this TOA here, this T here stands for, okay, let me just explain it. Let me take it over again. This S here, this is SOHCAHTOA, right? So this S here stands for sine. So if you look at this sign here, sine theta equals to opposite over hypotenuse. So S stands for sine, C stands for cos, and T stands for tan. Okay, so that is it. So for the S, let me start with the S case again. So S here, S, for S we have OH. The O stands for opposite and the H stands for the hypotenuse. So sine theta is opposite over hypotenuse, and then for cos theta is adjacent over hypotenuse, and for tan theta, which is TOA, is opposite over adjacent. So you can see it directly from here. I see it directly from here. So that is it. Okay, so that is it. Let me erase so that we can, let me just clean the slide. So the mnemonic SOHCAHTOA is very useful. Okay, you have to know it. That is the only way you can easily memorize all these formulas. Okay, let's continue. Okay, now let me keep the SOHCAHTOA for the simpler way that I can easily understand. So that is it. We have S equals opposite over hypotenuse, C equal to adjacent over hypotenuse, and T equals to opposite over the adjacent. So that is it. Okay, now I think we are actually going to look at the examples. So we are to look the examples under sine. Okay, that is the first case, the sine of an angle. Now the reason why I decide not to take sine and then I explain with the examples, I give examples and solve, is because I actually want to give all the trig ratios at once, so that we can actually understand it easily from the SOHCAHTOA. Because if I give sine and then I solve examples under sine, then I want to come and explain for the mnemonic, it will be actually, I might do that in the next video, since I don't want the video to be too lengthy and increase the cost of megabytes. That is why I decided to just do all the trig ratios at once here. Okay, now we're going to look at examples under sine. Okay, let's begin with example 1. So we have find the length of AB in the diagram below. So this is the diagram, and then we can label the diagram A, B, C. And then, okay, now they are talking of find the length of AB in the diagram below. So where is our length AB? So actually this is our length AB here. This is AB. Okay, now what do you notice? They cannot just ask you that you should find the length AB just like that without giving you one of the sides of the right angle triangle. Okay, the angle is given, the angle. So notice that our angle here is theta in this our consideration triangle. The triangle we consider, our angle here is theta, but now theta is actually unknown. So here unknown means you don't know it, you don't know the theta. But in this our example, they have given us 22 degrees. Okay, so that is, it means theta is actually known. Theta is 22 degrees. Now they are asking for AB. Okay, but what do you notice? You notice that this is our angle, this is our angle here, and opposite the angle is AB. Now they must give one side of the triangle. But now since we are dealing with examples on sine, you notice that one of the side given there is 80 meters. And what do you notice about 80 meters? 80 meters is the side CB. Okay, and the side CB is actually the hypotenuse of the right angle triangle. Now let's understand something important here. We know that CB is the hypotenuse and AB is the opposite. Now let's go back to SOHCAHTOA. Anyways, I'll just explain as I will be solving there. Okay, you notice that from the diagram, BC equals to hypotenuse and AB equals to the opposite. Okay, now from SOHCAHTOA, what do you notice? We notice that from SOHCAHTOA, let me explain it well. From SOHCAHTOA, we have from the right angle triangle that AB is, we are looking for the length AB, and the length CB is given, and we know that BC is the hypotenuse, CB or BC, but it's good to call it BC, so I start alphabetically. So the length BC is the hypotenuse, and AB is the opposite. Now let's move now to SOHCAHTOA. So SOHCAHTOA, where do we have opposite and the hypotenuse? Since opposite is given and the hypotenuse is given, they are asking for AB, which is the opposite, okay, and the hypotenuse is given. Now you notice that if we use cos cannot go, because cos is talking about the adjacent and the hypotenuse, while tan is talking about the opposite and the adjacent, but sine is talking about the opposite and the hypotenuse, and that is it in an example. Okay, so we're actually going to use sine. Now we notice that sine theta equals to, now let's move back to our formula. This is our formula. Sine theta equals to opposite over hypotenuse, which is equals to AC over AB. Okay, from this formula, sine theta equals to AB over BC from this diagram here, okay. Now, but we know that BC equals to 80 meters, but we're actually looking for the length AB. So we're actually looking for AB. This is our AB here. We're looking for AB. Now, but we know BC. So we take this BC, 80 meters, and then substitute it here. We put it here where we see BC. Okay. And our angle also, our angle given is 22 degrees. So we also take this angle and put it where we have theta. Okay. Since the angle is theta. Okay, if that is done, we are going to have that sine 22. We are going to have that sine 22 equal to AB over 80. Okay, but since we're asking for AB, so here we are just going to cross multiply so that 80 can multiply with sine 22. Since we know sine 22, and you can use a scientific calculator to verify sine 22, but you can still leave it like that and punch it at once. 80 times sine 22 will give you the answer. Okay, but now since we don't know AB, we are going to cross multiply, and if that is done, we are going to have that AB equal to 80 sine 22. So this is it here. AB equals to 80 sine 22. Now if you take a calculator and then you punch this, let me just punch it, 80 times sine 22. So we are going to have that AB equal to 29.97. It's actually 29.96, but you have to do what we call round up. So in mathematics, when we do round up, okay, so that is it. Okay, so that is AB. Okay, let's continue. Okay, I have some assignments. I have to do some assignments. You can also present a solution to the comment section, or you can present a solution via the number displayed to you on your screen on WhatsApp, so that I might do some useful corrections there. Okay. Okay. The number 2, right? We are going to solve number 2. Okay. We're actually going to solve number 2. And find the length of AB in the diagram below. Okay. Find the length of AB in the diagram below. Now they're asking almost a similar question. Now the length of AB. Now this is a similar case. You notice that the angle is given now is 25 degrees and the triangle is ABC. And as I earlier told you, for you to find the length, one of the angles must be given. So that is it. And one of the sides must be given. So let's look which of the sides is given for us to find AB. And what do you notice about AB? AB is a hypotenuse. So that is it. So you're actually going to present a solution in the comment section on WhatsApp. Okay, so that is it. Okay, let's look at number 3 of the video. Number 3 of the question. Number 3 is also an assignment. Okay, but from the example 1, we can actually solve these two assignments. Okay, so that is it. Now use your calculator to write down the value of sine 12, A sine 12, B sine 18.75. So that is it. Okay, let's now move to the next. I think we are going to move now the examples. We are going to look at the examples on cos and the tan. Okay, so let's move to the okay. We are going to look at our examples on cos or the cosine. Okay, find the length of AB from the diagram. So that is a diagram displayed to you. Now the same case, you cannot just look for the length AB without giving one of the sides, like in the case of sine. Okay, now this is examples on cos. Okay, so let's look at the side that is given. We have 120 meters. So the length AC is 120 meters, and actually they're asking from the diagram the length AB. Okay, now you notice that the length AB is actually the adjacent. Okay, is the adjacent because it lies just beside the angle, the angle 38 degrees. Okay, this is the adjacent. And then let me explain it better. Okay, so the length AB is the adjacent, and they are asking for it. So they're actually asking for the adjacent. And what do you notice about AC? AC is the hypotenuse. So let's look at from SOHCAHTOA which trig ratio is talking about the adjacent and the hypotenuse. So because you are going to use it, but since the example is actually on cos, it will be actually cos. Okay, but for verification, maybe they might give you another question that look for it. So I'm just explaining so that you can easily know the relationship. So in this other video, in this other example, is we are looking for adjacent, the relationship between adjacent and hypotenuse, which trig ratio have it or has it. Okay, that is it. So solution, you see from SOHCAHTOA again. So all these examples you are actually going to solve them using SOHCAHTOA. Okay, so the mnemonic is very important in mathematics, specifically trigonometry. It's very important in trigonometry, dealing with these trig ratios. Okay, now from SOHCAHTOA, we notice that from SOHCAHTOA, it implies that AB equals to adjacent, as I explained earlier, and AC equals to the hypotenuse. Okay, now since we are dealing with adjacent and hypotenuse, we notice that from SOHCAHTOA, if we begin with S, we notice that S is talking about opposite and hypotenuse. Then C is talking about adjacent and hypotenuse, and T is talking about opposite and over adjacent. Okay, so we're actually going to use cos because it's talking about adjacent over the hypotenuse. So cos is exactly what the trig ratio we are going to use there. Okay, so since I'm going to use cos, we have that cos theta equals to AB over AC. Since cos is the adjacent over the hypotenuse, and the adjacent is AB and the hypotenuse is AC. But we know that AC equal to 120 meters. So it definitely implies that I'm going to substitute my angle theta, which is 38 degrees, from this formula. Right? From here like this. This is the formula. I will substitute, since I know my angle, which is 38, I will substitute it here, and then I know my side AC, so I'm going to substitute it here again. So if that happens, we have that cos 38. We have that cos 38 equal to AB over 120. But we're actually looking for AB. Okay, we are looking for AB, so we are going to cross multiply this 120. If you cross multiply here, this place is like saying cos 38 over 1. Here it's like saying cos 38 over 1. Okay, so if you cross multiply like this, we know that we have that this AB will multiply with this 1. So AB times 1, I know in mathematics anything multiplied by 1 is the same thing. Okay, it's the same thing. So this 120 will multiply with cos 38. And if that happens, let's say we are going to have that. If that happens, we are going to have that AB equal to 120 cos 38. And you can take a calculator, a scientific calculator, and then you verify it. So that is AB. So AB is 94.56. So that is AB meters. That is it. Okay, so let's move to the next one. Number 2. In this number 2, we are still dealing with cosine. Okay, we are still dealing with cosine. Cosine, sorry. Okay, so in number 2 case, we have find the angle theta from the diagram. So let me display the diagram to you. So that is the diagram, and we can label the diagram ABC. So that is it. And they're asking for the angle theta from the diagram, but actually you cannot look for the angle theta without giving you two sides. So either the adjacent must be given, or the opposite given, or the hypotenuse given. So they must give you two of the sides. Okay, so let's look at which of the sides are given. So we have one side is given 120 meters, which is the hypotenuse. AC is 120 meters, and we also have that AB is 94.56. Okay, now look at this. Is the reason why I decided to choose this other case here, because we solve this. You notice that our answer here is 90. Look at this other example here. Look at this answer here. This answer here is actually 94.56, right? And we were actually looking for the length AB. So this is the length AB in this other triangle here. This is the length AB. Okay, now they have given us a length here, and they're saying the same length here AC is the same here AC also, which is 120 meters. Now we're actually looking for the angle theta, and you notice that the angle theta that was given in example 1 here is 38 degrees. So it definitely means that since everything is given but not the angle, we are actually solving for the angle. And since we are solving for the angle, it means that our answer should be approximately equal to 38 degrees also. It should be either 37 point something, but it should not be, it can never be 39. Okay, can never be 39. Okay, it can only be 37 point something, or exactly 38. So you notice that since I've used the same length given, so it means the answer should be closer to 38. Okay, 38 degrees. Okay, so let's continue. So we have that we notice that AB is the adjacent and AC is the hypotenuse. So we use cos. Okay, we use cos. So this is the AB is adjacent. So this is adjacent the angle. This length here is adjacent this angle here, theta, and this other one is the hypotenuse. Okay, so if we use cos, what are we going to have? If we use cos, we are going to have that cos theta equal to AB over AC. Now what is our AB? Our AB is 94. It's 94 point. Let me erase so that we can actually. Our AB is 94, and cos theta is AB over AC, and our AB is 94, and our AC is 120. Okay, so that is it. Now you can just take a calculator and then you punch you can just substitute the values. Okay, since we are looking for the angle theta and we know that AB is 94.56 and AC is 120, so we are going to have that cos theta equal to 94.56 divided by 120. So you can actually divide it. In this case, first of all divide it. Take 94.56 divided by 120. Then you keep the answer. Okay. If you keep the answer now, you take the cost inverse of the answer. You actually have the angle theta. Okay. So let's look at it. So we have cos. Now if you take 97 divided by 94.56 divided by 120, you are going to have 0.79. Okay, so that is it. Now we are going to look at cos inverse of this answer. Cos inverse means you would take your calculator. Let me explain it. You take a calculator and then you put the cos inverse of this answer such that you have theta equal to cos inverse of this answer. Take a calculator and do it like that. Now on your calculator, on scientific calculator, you press shift. If you press shift, look at the shift button. Is let me just check my calculator here. The shift button is at the top left hand side. Okay, so that is it. So if you press the shift button and then you press cos where you see cos, so you see the cos inverse, then you put a bracket there, then you punch the answer 0.79. okay, so you have the answer that I punched there. I have 37.81. 37.81. So we have that theta equal to 37.88. 81, you can just leave, you can round down, so we have 81. What do you notice? In the diagram we have 38, so here we have 37.8. so why is it not actually 38? It's because of the round up. If you notice that here this is 0.79. it's not actually 0.79, okay, because I ran up this value. That is why. So that is it. It's actually closer to 38. Okay, so that is it. So that is the value of theta. Okay, so let's continue. So let's now move on examples on the tangent of an angle. So we are going to now to tan theta. We have looked at sine and cos. And under sine I solved 2 examples. I think 1. Under cos 2. Now let's look at tan. Okay, so this is tangent of an angle. Alright, so example 1, we have proved that BC equal to 36.02. so this is a proof. Okay, this is actually a proof. So we are going to prove that BC equal to this 36.02 meters from the diagram below. Okay, let me display the diagram. So that is the diagram. You notice that they have rotated the right angle triangle. Okay, they have rotated it. Now they are asking BC. Now as I earlier told you, they can never give you a triangle just like with the angle. They ask you to look for the other length without giving you the other length. No, they can never do like that. They must give you one of the length. Okay, let's see the side that is given. So the side that is given here is 40 meters, which is AB. So AB is actually 40. And what do you notice about AB? AB is actually the adjacent of the triangle. Okay, AB is actually the adjacent of the triangle. And BC is actually the hypotenuse. Now it means that they're actually asking us to find the opposite of this triangle BC, which is the opposite, because it is opposite this angle here. Okay, that is it. And this is the adjacent. Now we are going to look at the relationship again. You notice that from SOHCAHTOA, right? From SOHCAHTOA, let me explain. From SOHCAHTOA, AB equal to the adjacent and BC equals to the opposite. Okay, so that is it. Now let's begin with S. So S is talking about the opposite. It's talking about opposite over hypotenuse. But we have they're actually asking for the opposite, but the hypotenuse is not there. Okay, so that is it. The hypotenuse is not there. Now let's look at cos. Cos is talking about the adjacent over the hypotenuse. Let's look at it again. Is the adjacent there? Yes, this is the adjacent. BC is the adjacent. AB is the adjacent. Now cos is talking about adjacent over hypotenuse. Is the hypotenuse there? No. So the hypotenuse is not there. Now let's move to tan. T. T is talking about opposite over adjacent. Is the opposite there? This is the opposite here that they are asking. And is the adjacent there? Yes, this is the adjacent. So actually we are going to use tan. Okay. So this is the way that you are going to be checking things when equation is displayed, when equation is given to you in your exams. Okay, so that is it. Now if you look at things well, actually I made a mistake here when I was typing. There was solution, it was supposed to be solution before from SOHCAHTOA, so that is a mistake, I think, when I was animating. Okay, now we notice that the solution now from tan theta equals to BC. Since tan is talking about the opposite over the adjacent, and the opposite here is BC over the adjacent, which is AB, and AB is 40 meters, and the theta is, the angle given is 42 degrees. Okay, so if things are done well, we are going to substitute the values, substitute theta and substitute AB, and theta is 42 degrees. So this is our theta. Our theta there is 42, and our BC is 40. Okay, so that is it. Now we are still going to, since we have to look for BC, we'll cross multiply. So cross multiply like this, and here is like saying divided by 1, and you know 2 divided by 1 is 2. Anything divided by 1, different from 0, not 0, but any other thing divided by 1 is the same thing, but not 0. Okay, so if you cross multiply, this BC will multiply by 1, and if you multiply this by 1, we are still going to have BC. And if this 40 is multiplied with this tan 42, we are going to have 40 tan 42. Okay, so that is it. And if things are done, we are going to have that BC equals to 40 times tan 42. So you can actually take a calculator and punch it directly. And if that is done, we are going to have that BC equal to 36.02 meters. And that is the proof. So we have proven it. Okay. So let's continue, please. I hope it is clear. Okay, so let me give some other assignments so that you can practice it. You know, mathematics is all about practice. Okay, so number 1, we have, from the diagram, find the length AB. So this is the diagram here. That is the diagram displayed there. Okay, that is the diagram ABC, a triangle ABC. Now they're asking you for the length AB. Now, if a question is displayed to you like this, 1, since they're asking for the length AB, check for the other side. Is the other side given? Yes. So let's see the side that is given. So the side BC is given, and now that is the first step. Now in the other step, now look at where the angle lies, and then you look for the opposite and the hypotenuse and the adjacent. Now they have given you BC. Is BC the adjacent? Yes, because it's adjacent the angle. Okay, it's adjacent the angle. So that is it. Now let's look now for our opposite. So where is our opposite? So from the diagram, which side is opposite this angle? So this is the angle 46 degrees. Now opposite this angle is AB. Okay, so that is it. Opposite the angle is AB. So that is it, and this is our hypotenuse. This is our hypotenuse AC. Okay, so that is it. You do things there, you notice that it is somehow easy if you focus. Okay, now let's look at assignment 2. Now find the angle alpha from the figure below. So this is alpha in this is a Greek symbol called alpha. Okay, so that area is actually called alpha. This is alpha. Now from the figure below, okay, let me display the figure to you. So that is the figure. They're actually asking for the angle alpha. Now if they're asking for an angle, it means that either one of the sides, 2 of the sides must be given, or they can just give you a value that either the sine of that angle equals to that value, or the cosine of that angle equals to that value, or the tangent of that angle equals to that value. Okay, so that is it. Now let's look at the 2 sides that are given. So we have 5 meters and 3 meters. Now let me just give you some hints. You notice that this is our angle alpha here. This is our angle alpha. Okay, now opposite this angle is 3 meters, and which is BC. So BC is actually 3 meters and is the opposite. Now let's look at AB. AB is actually the adjacent. So AB is the adjacent, is 5 meters. Now it means the opposite is known and the adjacent is known. If that is done, now move to SOHCAHTOA. Since we have our opposite and the adjacent. Now if you move to SOHCAHTOA, we notice that, so this is SOHCAHTOA here. Come back here, I'm here. This is SOHCAHTOA here. You notice that by comparison, so the beginning of the S is opposite over the hypotenuse. Is the opposite known? Yes. This is the opposite here. The opposite is 3 meters. And so we have the hypotenuse. Now is the hypotenuse known? No. The hypotenuse was not given. Okay, and then let's move to car. Car is talking about the adjacent over the hypotenuse. Is the adjacent known? Yes, adjacent is 5 meters, AB, which is 5 meters. Is the hypotenuse known? No, AC is not known. So we cannot use car, we cannot use cos. Let's move to tan theta. Tan is talking about opposite over the adjacent. Is the opposite known? Yes, which is 3 meters. Is the adjacent known? Yes, 5 meters. And then from there you can proceed with the solution. Okay, so that is it. And we have finally come to the end of the video. So that is it. Please, I recommend that you like, share to your friends, and subscribe. In another video we will continue where we stop. Okay, thanks.